Everyone, welcome to CSCI 287 Data Structures Hands-on Practice. In this video, we will introduce single linked list implementation in Java. In particular, we will focus on how to implement the add method and the linked list class. The purpose of the add method is to add a new node with a specified value to the end of the list. Therefore, the return of the add method should be a linked list. And the input of the add method should include a linked list and a specified integer value. The first step is to create a new node for storing the specified integer value. To achieve this, we create a node object and name it new node. To implement this method, we have to consider two scenarios which will be described later. Here, we use an if-else statement to handle different scenarios. If the condition is true, we will handle scenario 1. Otherwise, we will handle scenario 2. The first scenario is that the single linked list is an empty list, where the head of the list points to the terminator or null. In this case, we can simply add a new node with the specified value in the linked list and set the head of the list points to the new node. If the list.head is null, which means the list is empty, so it's an empty list, and add the new node as head. The second scenario is that the single linked list has one or more nodes in the list, where the head of the list points to the first node. In this case, we need to traverse the list by following the pointer in each node until we find the last node where its pointer points to the terminator or null. Once the last node is found, the pointer in the last node will be set to point to the new node, where its pointer points to null by default in the constructor. In order to handle scenario 2, we need to traverse to the last node and add the new node at the end. So the first step is we want to create a node object to hold the current node. And the current node is from the head. The next step is we want to traverse the linked list using a while loop. So the loop condition is we will continue looking for the last node if the current pointer is not null. When the current pointer is null, which means the last node, then we can quit the loop. If the current pointer is not null, then we will make the next node as current node. So once we quit the loop, we can add the new node to the end of the list. Now we can save the code and try to compile it and try to test run it. Okay, so you can see no problem. All right, so we will talk about the other method in the coming video. Thank you. Bye-bye.